Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, I want to continue frame analysis. Actually, this is step number 4. I have actually done uh, 8 videos regarding this example. Start with the first introduction to this frame with inclined column AB, and then we have video for step number 1, where step number 1 we calculate K stiffness factor as well as distribution factor for each element. And for the next video after that is about step number 2A, where under step number 2 we analyze no side sway frame, and under 2A we actually calculate fixed end moment due to external loading. Okay, due to external loading, before we use the external loading, the FEM due to external loading into the table number 1. And table number 1, I have discussed the video next after 2A, step 2A video. Okay, I have actually explained the detail about distribution table. We use the FEM we put into the table as the first member and moment in the table, and we do distribution as well as carry over the value. We repeat the process, the cycle, we repeat again and again until the moment reaches zero value. So in the table, once moment reaches zero value, like this 0.0 something, so we may stop the calculation, we may stop the process, and then we total all the moments, start from the first moment in the table, which is FEM, until the last distribution. So finally we sum all the moment, and we get the end moment from the first table. We label as M0. So this is M0 value. So this M0 value is actually uh, representing wait. Okay, this M0 value is actually represent the end moment for the frame. This is no side sway frame. There is no delta, because we have removed the delta by putting an imaginary support at C, so that the frame is properly restrained. So all the 6 value represent here actually the member end moment. So we have M0 for the end moment. We have 6 value for member AB, for N AB, BA, BC, CB, CD, and D, and DC. So uh, since we will actually apply the principle of superposition in order to find the total the total end moment or final end moment, because in original condition of the frame, the frame is unsymmetrical frame. So due to that, the frame will have combination of FEM due to external loading and side sway. So for the first part, we actually only consider FEM due to external loading only. So we will have the second part where we have to consider delta or side sway only. So this is the first part. So we relate between first part and second part using what we call as restraining force. So we have to actually find the value of restraining force. So the restraining force is come from the imaginary support that we put at C, so that we remove or we change the condition of frame to properly restrained frame. So due to that, there will be a restraining force acting in left direction here, left direction. So due to that, we will write the shear equation. Okay, shear equation. Why we shear equation is actually the equation we want to include all horizontal forces as well as horizontal reaction under one equation, because we have R as unknown now, and we want to determine the unknown. So have to have we have to consider all horizontal forces as well as horizontal reaction in one equation. So that equation is called as shear equation. Shear equation. So we have to write the shear equation. Okay. uh but before that, we have to understand that all end moment we can actually draw the free body diagram by element like this. So this is the free body diagram for internal forces in each member A, B, B, C, and C, D. Okay, take note that there are three type of internal forces in X, Y, and Z direction. X, Y, and Z direction. So for member AB, so we just need to label, okay, the X and Y in as V1 and H1 for member AB. And we have to put the moment that we get from the table. So the moment MAB we get from table 6.639 and 13.288, we put in the in the diagram for member AB, for member AB. And then the system must be in equilibrium. System means we have to make sure that the structure is in equilibrium, the element is in equilibrium, the joint also in equilibrium. So when we draw it separately like this, so we have to make sure that for element also, we have to check for total fx 0. So so we have h, uh, we will have H1. H1, this H1 will be equal to this H1 to remain equilibrium. And this V1 is equivalent to this V1. Actually, this V1 is equivalent to AY, H1 is AX. Okay, this is just to show that the value is actually the same because we have to remain equilibrium. So this is moment that we get from table. So we have to draw element by element. So for element CD, we have to draw the column CD. So for column CD we have 2n, and C we have this as the moment that we get from table, and this is the moment that we get from table as well. And beside moment, we have to put also the vertical reaction, and vertical and horizontal reaction, or vertical as well as horizontal forces. So this is V2 or dy. So this one will be equal to this to remain equilibrium. So H also same. So the difference between AB and CD, AB we declare as 1 V1 H1, and for column CD we declare as 2 V2 H2. So and after that we have to check for the equilibrium for B, and we have to check the equilibrium for C. So that is why we get this one and this one is equal, which V1 is equal to AY, and we get V2, and this V2 and this V2 is also same, and actually V2 is equal to dy. And of course H1 is AX and H2 is dx. Okay, so we will start the analysis by analyzing member BC, beam BC, in order to calculate the dy value as well as AY value. So once we get AY value, because what we want is actually the shear equation. Shear equation is R. Okay, is R. So from the shear equation, actually we get okay, from the shear equation we get we need to have AX and DX. We need to have AX and DX. So we calculate AX and DX using static equilibrium, then we get the value. So and then we substitute into the shear equation, and then we get R is equal to 12.59. So actually I have explained this in quite detail under video for step 2 to B and to C. Okay, and then we will move to part the second part of analysis, which is step number 3. So step number 3, we focus on side sway frame. Side sway frame, actually we now want to consider the fixed end moment due to side sway only. So we have to remove delta. Sorry, we have to remove external loading. All external loading we have to remove, and we just need to consider delta to calculate FEM. So this one also I have explained quite detailed under video step 3A, 3B, and 3C. Okay, so I skip this because this is actually video regarding step number 4. So actually under step number 3, B and 3C, will be equal with to B and to C. So that is why I just put the summary value here. Okay, so now we move to step number 4. Okay, in step number 4, we will calculate in step number 4, we will calculate the final end moment. Final end moment, actually it is come from the basic concept. The basic concept explained in the textbook. So the basic concept everyone should actually understand about this basic concept. Okay, this one is the concept. Actually, this is I get from the textbooks. This is the concept, how we get the final equation. Actually, how we get the final equation. So for the equation, for the final equation, actually we have to understand about this simple concept. Okay, okay. In real, we have combination of P, which is the external loading, and we have delta, which is side sway. So actually in original condition, the frame has combination of P, external loading, and delta, and delta means side sway, and we cannot calculate FEM for external loading and delta together. So that is why we have to separate it. We have to calculate external loading in one table, and we have to calculate the base. We have to analyze the delta separately. We have to analyze P separately. We have to analyze delta separately. Okay, so that is why we need to divide the system, divide this P and delta into two, divide into two. But the final answer we must include back combination of P and delta. So this is M final. This is M final. So this is what we want to calculate actually. Okay, so for the final end moment, I label as MF, or M total. So we have to divide into two. So we want to have one frame which we remove delta, and in order to remove delta, we have to put this pin support. Pin support is an artificial support, and by having this support, there will be a restraining force. So this is actually the horizontal reaction that is exists towards the pin C. Okay, so by putting this pin support, the frame is now properly restrained. So the properly restrained has cannot move. The properly restrained cannot move. So analyzing this frame is actually table number 1. Analyzing this frame is actually table number 1. And from table number 1, we have labeled the end moment that we get as M naught. We have labeled as M naught. M naught. Okay. And please remember, M naught is only the half part of analysis, where we get the value from external loading. Don't forget, we have another one, which is delta. Okay. So by applying principle of superposition, so we will get like this. Means that we have to neutralize the R. Okay, we have to neutralize the R. Means this, if this is negative R, we will have positive R. So that we will get back 0. Here the R is 0. Okay, there is no R actually. And then by uh, uh, fulfill, okay, the principle of superposition. So P also, we have to apply the principle of superposition to get P. This is to get P, it is P plus 0. So here is 0. So P plus 0 equivalent to 0. So that is why we have the diagram. The diagram due to side sway only, and the frame is subjected to R in opposite condition. One is negative R for the properly restrained frame, table number 1, and another one is positive R. This is side sway frame. Side sway frame. Okay, side sway frame. So the moment due to side sway, the end moment due to side sway, we label as M. The moment due to side sway or due to R, due to side sway, we label as M. So from this we get the equation. This is actually representing principle of superposition. MF equal to M naught plus M. M naught plus M. So this is how we get the final equation. Anyway, M naught is we get M naught from table 1, and we do not get uh, M from uh, we do not get M from table 2. M is not from table 2. M is not from table 2 because we do not know the delta value. Delta is here, but delta is unknown. P is given value. External loading is always given in the question, but delta is not given. So when delta is not given, we normally calculate or analyze table 2, the frame in table 2, by actually analyzing another diagram due to R prime. That is why we actually analyze another frame, the same type of frame subjected to R prime. This is the one that we analyze in table number 2. This is the one that we analyze under table number 2. Table number 2. So this is the diagram, ABCD diagram. This is table number 2 because we cannot assume the FEM for C, but we can assume FEM for D. Okay, for D due to R prime. So this is table number 2, and the end moment from table number 2 we label as M. We label as M prime. M prime. Okay, so that is why under table number 2, all we label as prime because we analyze diagram D, not C. Okay, diagram D, not C. Okay, so how we get the final equation for the end moment? We actually comparing these two diagram. Of course, here we have delta prime. Okay, so from table number 2, we actually calculate M prime from table number 2, and from table number 2 also we calculate R prime. Okay, and in C diagram we have R value here that we get from table 1. Okay, this R we get from table 1. So means that this R is now known value. So this is known value. So comparing these two diagram, we get M as the unknown. M as the unknown. So actually by comparing these two frame, it is just like we analyzing two triangular using interpolation. So this two diagram, we relate the M and R as well as M prime and R prime using what we call as interpolation. So interpolation between M, R, M prime and R prime. So we have M, R, M prime and R prime. So from this we get M, which is equal to, we group R as R prime and R prime together, and we times by M prime. So this R divided by R prime is called as correction factor. Correction factor. Okay, so this M, which is equal to R divided by R prime, times M prime, we substitute into the formula. So that is why the final end moment we get M plus M naught plus M, and M naught is plus M naught plus M, and M is R divided by R prime times M prime. So this is why the final moment equation we get from this equation: M naught from table number 1, M prime from table number 2. We analyze under step 2C, we get R. We analyze under step 3C, we get R prime. And when we combine together, so we get one equation. Because R and R prime, we can calculate the value, so we get one equation. So use this equation to calculate the final and moment. So the summary of this, okay, is given in the table like this. So the first row is for the M node that we get from table number 1, no side sway frame. M prime is actually the end moment that we get from table number 2. This is side sway frame, and we have the correction factor. Correction factor is actually M naught. Okay, we have this as R prime value. Okay, we just need to replace this. And R value is actually 12.59. 12.59. 12.59. So from this we get the correction factor is equal to 12.59 divided by 49.222, we get 0.256. 0.256 times negative 78.286, we plus with 6.639, and we get the final end moment equivalent to, for AB, is equivalent to negative 13.3.386. Okay, 0.386. So the final end moment, there are 6 value for AB, BA, BC, CB, and CD, DC. Okay, so that is step number 4. We calculate the final end moment using principle of superposition. We have to understand the concept, okay, where we analyze table number 1 from M naught, and based on diagram B, and we actually have calculate table 2 based on diagram D, not diagram C. Okay, that is why all under part 2, the side sway frame, we have to put the prime. We have to put prime for all label that we use. So finally we get the correction factor, and we total all, and we get the final end moment as shown in the table. So that's all for video number 9. Video number 9. So inshallah I will continue video for video number 10, uh, explaining about how to draw bending moment diagram using the value that we get from moment distribution method. Thank you very much. We will meet again in the next video.